So today we are looking at quadratic word problems, in particular, projectile motion. So let's read this example 1 and see what the heck is going on here. Using the graph at the right. Wow, you guys are loud today. It shows the height h in feet of a small rocket t seconds after it is launched. The path of the rocket is given by the equation right here. H equals blah, 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 blah. So, take a look at this graph. So, understand what's going on here. You are shooting a rocket. The rocket's going to go up in the air, right? And then at some point, it's going to turn around and come back down. Guys, I have no problem sending a link to this video to your parents and saying, hey, listen, this is what your kid's putting me through. Huh? Oh, yeah. Oh, yeah. I have no problems with that. Anyway, so you launch a rocket. It's going to go up in the air. It's going to turn around. It's going to come back down. So this graph shows us the height of the rocket over time. Okay? Now, furthermore, they give us an equation that models this rocket. So at any time, if I want to know how high is the rocket at 2.3 seconds, I can find out. What would I do? Plug it in, right? My graph is good when it hits at nice points, right? But if I want 2.3, I don't know where 2.3 is on the graph, I can always use the equation, okay? Now, if I asked you a question like, how high does the rocket ever go? Where is that happening? At the vertex, right? The maximum point of the whole parabola. So if I ever ask you a question like, how high does the rocket go? Or the ball, or the rock, or whatever it is we're talking about, because it's all the same thing, right? That's going to be something that happens at the vertex. If I ask you for the highest or the lowest, if we had it going the other way. So, maximum, if I ever ask you for what's the maximum height that you ever get to, you're just really looking for the vertex. Now, what part of the vertex? The x-coordinate or the y-coordinate? In this case, it would be the y-coordinate, right? You wouldn't say that the highest that the rocket ever got was 4. No, that's time. What does that 4 mean? It took 4 seconds for it to get to its highest point. Right? So that's another type of question I could ask you. How long did it take for the rocket to reach its maximum point? That's another that's another question answered by the vertex. So the vertex will give you 2 bits of information. The highest the object ever goes and how long it took to get there. So just make sure that you're clear that the x-coordinate would give you the length of time it takes to get there, and the y-coordinate would be the actual height. Okay? Now, I know I have a graph right in front of me, but if I want to know how long is it going to take until it hits the ground? In this picture, it's very easy to tell, right? Can't you tell how long is it going to take before the rocket? 8 seconds, right? It goes up, and then it lands back here over at 8 seconds. If I don't have a graph, though, what am I going to do with this to figure out when the rocket's going to hit the ground? Plug in what? Someone said something. Which numbers? 0 for what? Yes! Guys, when the rocket hits the ground, isn't the height of the rocket 0? So if I want to know how long the rocket is in the air for, I'm just going to plug in a 0 for h. And then I solve for t. Oh. Now, this is all a lot easier when I have a graph laid out right in front of me because I can just look at it. But usually you don't have a graph. And you're not going to bother to take the time to make the graph because it takes so much longer. It's so much faster to just solve it algebraically if you know what you're looking for. Right now you do, but you won't pretty soon. Okay, so let's go through and answer the questions that they've asked us so far. You already answered number 1. How long is the rocket in the air? 8 seconds. What's the greatest height that the rocket achieves?
275.
Well, you got to figure out what's the scale. Every line is worth 10. So 260. And what are our units? What units are we in, people? Feet. Huh? I think it's a good idea. Number 3, you'll notice, ladies, gentlemen, says about how high is the rocket after 1 second? I would say, don't you say 105? Doesn't it look like it's crossing halfway right between? I would say 105. Now listen, if I wanted to know exactly, without guessing, what could I do? I could go to the equation and do what? Plug in, someone said it, plug in 1 for t, because at 1 second, t would be 1. So if I just plug in 1 for t really quickly, that would get me out 112. So our estimation, another reason why the graph is nice to get an approximation. So I approximated at 105 when it's actually 112. Wow. That really doesn't look like it on the graph, but all right, they say so. So anyway, after 2 seconds, about how high is the rocket? So 2 seconds. Yeah, I'd say we're right at about 200. And is the rocket going up or down?
Yeah, I said 1
Up. And that's another thing that's very easy to see on the graph, because you know you haven't come down yet. If you don't have a graph, how would you know if you're on your way up or on your way down? You'd basically have to figure out where your vertex is. And you're going to need that for the maximum heights anyway. So if I know my vertex comes after 2 seconds, like if it's 4 seconds, like in this case, then I know, okay, it must be on the way up. If the vertex happened at 1 second, then at 2 seconds, I must be on my way back down, right? Right? Right. Okay. 6 seconds, how high do we think we are? 6. I think we're just under. I'd say 190 there, yeah. And are we going up or down? Oh, and I've been neglecting my units. Oh my gosh. Now here's an interesting question that is really best answered by looking at a graph. Do you think the rocket is traveling faster from 0 to 1 second or from 3 to 4 seconds? 0 to 1, absolutely. And what in the graph makes you think that? The line is steeper, absolutely. So 0 to 1 second, graph is steeper. Okay, now number 7, they want you to use the equation to find the exact value of the height of the rocket at 2 seconds. So everybody take a moment and find the answer to this, please. Everybody's got an answer? Okay, everybody got one? And the answer is? I heard some right numbers and some wrong numbers. I got 192. So we're plugging in 2 seconds, right? So in our equation, you're going to do negative 16 times 2 squared is 4, right? So I did negative 16 times 4. Plus 128 times 2. Be careful what calculator you're using because order of operation matters. So if you're using a fancy calculator, it can do it for you. Notice when I did it by approximating, my answer was 190. So I'm expecting a number gosh darn close to 190. So 192, reasonable. From the graph. If you look at 2 seconds, right, we had approximated it to be at about 190. Oh no, we approximated it to be at 200, sorry. At 2 seconds. At 6 seconds, we thought it was 190. Okay. Now, 8. Do you guys remember talking about domain and range? Yes, X is your domain value. So domain refers to X's, range refers to Y's. Guys, domain and range is not nearly as hard as you're making it out to be. Domain is just asking you, all right, look at the graph. What values of X are shown in this graph? Isn't it just 0 through 8? That's it. So my domain is 0 through 8. So in other words, the right way to write this, you would do it kind of like this. I have X is between 0 and 8, like that. And then the range is just the Y values, and the Y values go between what and what? Careful. Where did they actually start? 0 up to 260, was it? Yeah. So my range is just between 0 and 260. Oh, sorry, I messed that up. That's it, guys. It's not that bad. It's just what X values are represented, what Y values are represented. So if I gave you, let me throw some arrows on this. Take this graph right here, this absolute value graph. I know the people on the video won't be able to see this, but if you are on the video in internet land and you want to know, we're looking at the graph of the absolute value of X minus 1. Anywho, if I ask you about the domain and range of this, notice that the branches of the V continue to go on to the left and to the right forever. They're never going to stop. So what X values will be represented?
Anything less than 0 and anything greater than
The answer I'm looking for is all of them, right? This graph is going to continue this way forever and this way forever. So every single X value will be covered eventually, right?
Yes.
So the domain for this graph is all real numbers. Every X value in the whole wide world will be covered by this graph. Is the same thing true for the Y's? No. Notice both branches are pointing upwards, up and out, but are they ever going to come down here? No. So you will never, ever, ever get a Y value down here. So which Y values will you get? You'll get all the Y values that are greater than or equal to -1. So that would be the range of this one. You're never going to get Y values down here, because this graph never comes down here. It goes this way and this way forever. So does that kind of make sense? X values, I'm going to hit every X value on the whole coordinate plane in both directions. But I'm never, ever, ever going to get a Y value of -14, for example, no matter what I plug in for X, because they're all going to be up there. That's never coming down here. Okay, so there's a little spiel about domain and range. It's not that big of a deal. Okay, so don't worry about them too much. Once you get it, they're all right. All right. 10 is just asking you where's the graph increasing, and 11 where's it decreasing. So where are we increasing from? 0 to
260.
Well, I'm thinking in your, in terms of time. Yeah, from 0 to 4 seconds I'm increasing, right? So I would write that like this. From 0 to 4 I'm increasing. And then where am I decreasing?
From 4 to 8.
Yeah, 4 to 8. Now I'm in the decreasing land. Actually, I guess if we're going to be technical, when it's exactly at 4, is it increasing or decreasing?
No, it's like
Neither. It's kind of frozen in space for a split second, right? It goes up, and then it freezes for a split second, and then comes back down. So really, we shouldn't have or equal to 4, because at 4 exactly, it's not increasing or decreasing. It's steady.
4.1.
Yeah, so we shouldn't have the or equal to bar underneath.
So 4.1 and 3.9.
No, because then you get into, well, what about 3.99? 3.999. For the 4, no.
What about the
I wouldn't put it there either. Because when t is equal to 4, it's not increasing or decreasing. Is that my eraser? It's Liliana's eraser? Did you get that eraser from me? No. Okay. Just checking. I have those same erasers, and someone just borrowed that from me the other day, and I don't think I got it back. I don't remember who it was. Hmm? No, I believe her. But someone's out there has my eraser, my beautiful eraser.
You can have it if you want.
I do see a lovely eraser on your desk too. Oh. I thought it was an eraser. No. Hey, those are nice erasers. I'll tell you what. Yeah, no, it's okay. All right, guys. So there's some